Here we go. Dilations. So we're going to dilate with no grid. Let's see how this goes out. You'll need a ruler when you're doing this. So make sure you end up with a ruler. So here we could measure this distance from here to here. Let's say that distance, I'm just going to write a number down. Let's say it was 15. Since I want to do twice, I would do 2 times 15. And I would mark my new point. The biggest part of all this, you always have to start at A. So then my new line would go out 30. Okay. Or let's keep it at 15. Again, always starting at A. Now you're going to do half of that. So we would do 1/2 times 15, 7.5. I would always use centimeters if I were you, just easier to manipulate and work with. So we'd have 7.5, and we would come out halfway. And there would be D, and C would end up out here, double the distance out here. Okay? But again, you've got to measure the distance from A out to B and get this distance. Then double it, half it, start from A, measure out. Okay. How is it working similar to previous? We didn't do circles. How can we describe C as a dilation of B? It's a double the distance. And D. All right, let's see this obstacle course. What do we got here? All right. So again, what we're going to be looking for is what is called the center of dilation. That is a fancy word for starting point. That means you're going to start there. So we're going to start at A. We're going to dilate B, so we're going to move B by a scale factor of 5. So 5 times the distance from A to B. So take out a ruler, measure the distance from A to B is 2 centimeters. So we're going to look for something that is 10 centimeters, and that would be I. Okay, let's go to the next one. We're going to use H as our center of dilation. So we're going to start at H. And we're going to dilate G. So we're going to move G so that its image is on E, all the way out here. So we want to look and go, well, how far is it from? It's about 3 centimeters. And how far is it from H to E? It is roughly 9.5. So from here all the way to here is 9.5. So I would take my 9.5 divided by my 3. What does that give me? 3.16 repeating. That would be my scale factor. So roughly 3 is your scale factor, but not 3. It's more than 3. So H is this. What's the scale factor did you use to move from H out to G? Yeah, I still think that's 3. Yeah. So if I use H as my center, so I made it bigger. So notice this number is bigger than 1 because I moved G out to here. Now they're kind of going to reverse the process. All the numbers stay the same. So we still have our 9.5. And we still have our 3. But now, when I dilate E back toward my center dilation, I would do 3 divided by 9.5. 3 divided by 9.5 would be 0.32, 0.315789.4, but 32. What we want to look at here, this with this, they're inverses of each other. Okay? They're inverses. So if you multiply them together, you get 1. Those are inverses. So what happens if we dilate F so that its image is B? So I'm going to move F, and dilate F to get B. Moving it toward B here. That says what point on the diagram can be your center dilation? Well, it cannot be D because you can't have a negative. So then that means it has to be C. This has to be your center dilation. You had to measure from C to F, C to B to find out what that scale factor would be. So we're going to dilate H. So we're going to move H using A as our center dilation and scale factor 1/3, which point is our image. So I'm getting closer because this is less than 1. So this has to be my image. Describe a dilation that uses a labeled point as a center dilation, and that would take F to H. F to H. Describe a dilation that would do that. Well, we would need my center dilation to be E. So my center of dilation is E, has to be E because they have to be all in a straight line, and it cannot be G. So then what is my scale factor? Then I'm going to measure from E to F, which is 2.7, and E to H, which is 8.5. So I would say 8.5 divided by 2.7, 3.148, and that's repeating. That would be the scale factor. At any time, you can always rewind, pause, and look back and see if I erased something too fast. So let's look at number 7. Using B as a center dilation, dilate H so that its image is itself. So B is our center dilation. We want to dilate H so that it ends up on top of H. That would mean the scale factor is 1. Because at this distance, whatever it is, I would say let's just measure it. What is it? What is B to H? 4. Then what do I multiply by 4 to get 4? Multiplied by 1. All right, what do you notice about the scale factor G to E and E to G? Dilating E back to G, they were inverses of one another. What do you notice about the center dilation? The point being dilated and the image of the point being dilated, they're all on a straight line. They always line up. What scale factor results in an image that doesn't move? Scale factor of 1. So if I want to do, we want to dilate B using A as a center dilation, scale factor of 3. How could you perform this? Well, we know that dilate B using this as my center, then this C would end up outside of B. So I would measure from A to B, get a distance, multiply it by 3, measure from A out to that number. That would be your new. All right, let's look at perspectives. We're going to choose some point inside the circle. So I'm going to choose this point right over here. Then using the center C and the scale factor you were given, let's make our scale factor, let's do 1.25. We can do almost anything. I just got to stay inside the paper is the only thing. Using the scale factor, draw the image under the dilation of each vertex of the rectangle one at a time. Connect the dilation. So we need to know how far it is from here to each vertex. That was 1.5. This was 3.7. Maybe I should draw a line there. This line was 3.7. This line was 1.5. This line is 2. Oops. Don't try to move it. What is this line? 4. So I'm going to take each one of those, 1.5, 2, 3.7, 4. I'm going to multiply them out. So let's go through. I'm going to round 1.875 to 1.9 because that's all I can measure on my ruler. Now what I'm going to do is I'm going to come back in. So I'm going to start here at 1.5, line it up, make sure that it lines up. Oops, sorry. Hand touch the screen. Make sure that I line up with the vertex. Each vertex has to be lined up through the red dot to your new point. We'll make our new points blue. So it would be 1.9. So that would be right about there. This one would be 2.5. Right about, whoops, undo. Try to get better, sorry. Right there. 4.6. Oh, sorry, I'm going to do this one. The bottom, do 5. and 4.6. So that then if I was to draw in straight lines, that would be my new rectangle. And I could have a three-dimensional figure connecting up these. But you need those other black lines to do that. All right, that's the part we just did all of this. Here, if you want to find the center of dilation, use a ruler straight edge to find the center of dilation. Basically, we want to connect up D through D prime down as far as you can, and from E through E prime. And where those two lines meet, this would be your center of dilation, F. So then we can measure from E to F is 12. From E prime to F is 4. No, sorry, 3. So that would mean 3 divided by 12.25. Oh, this thing doesn't let me pause. Okay, let's finish up this. In our synthesis here, how would you explain the steps to dilate a point? Measure from your center dilation out to the point. Take it times your scale factor, then remeasure. So let's look at this one. Lynn drew a triangle. Dilation of a triangle with scale factor of 1/2. This tells me, because it's less than 1, her figure got smaller. So when it tells me that she did triangles, I only see 2 triangles over here. I see the big one, ADC, and I see the little one, EAB. So what's the center dilation? What letter didn't move? What letter's in both? A. It didn't move, it's in both triangles, and it did not move. So that's your center dilation. Which triangle is the original triangle? The original triangle, the big one, ADC. And which triangle is the dilation? So the image is AEB. That's the image. All right. Hope you watched all of it. Hope you paid attention, had your ruler, working through it, because you can now apply dilations to a polygon using a ruler.